Hey everybody, John here. Today we're going to talk about trigonometric identities and equations. So this whole last part of our course is all about algebraic manipulation, which might be something that people enjoy. I find that it's not something that most people enjoy. The whole idea of this section is to be able to write what we're given in a different form so that it looks like something else but hasn't changed at all, so that we can verify whether we've got it right or not, or just get answers from information that we have. So that is what this whole part of this last part of the course is about, is using algebra to do some plastic surgery on some equations or expressions. So plastic surgery changes the way something looks without changing what's really underneath. Okay. So our first thing is, you've seen this slide before. I gave it to you earlier. I wanted you to see it. We should already be very familiar with this stuff up here. These are definitions of tan, cotan, cosecant, secant. I don't consider these to be identities. I consider them to be definitions, but other people consider them to be identities. And then we have our Pythagorean identities. This is really what we're going to focus on today, is these three Pythagorean identities. Now, I'm not saying that you need to memorize these. Obviously, we're learning from home. If I give you an assessment, you'll have access to these. But in the future, if you were to do a course where these weren't given, really this first one's the only one that you need to know. And that is because if I know this first Pythagorean identity, which basically says x squared plus y squared equals the hypotenuse, which on a unit circle is the radius, which is 1 squared. So this is just the Pythagorean theorem. And if I know this, and let's say I wanted to get this second trig identity, I would just divide everything by cosine squared, because that would give us 1 as the first term, tangent squared as the second, and then over here, 1 divided by cosine squared is secant squared. So that gives us 1 plus tan squared t equals secant squared t. So that's our second Pythagorean identity. We can get the third one by taking this first one and dividing everything by sine squared, and that will give us that third one. And then we have our even-odd identities. These are the things that we talked about earlier in this semester. Symmetry about the y-axis is what an even function is. Symmetry about the origin is what an odd function is. And this is where these identities are coming into play now. Again, you'll have these all because everything's going to be open notes, basically. I can't stop you from using it. So, all right, let's move on to our first example. So we're going to use the Pythagorean identities to figure out the value of tan of theta, given that cosine of theta is negative 5 over 13. Okay? So basically what I'm going to try to do is I'm going to look for the Pythagorean identity that has a cosine in it and a tangent in it. Now, you might be looking at this list and saying, well, there are none that have cosine and tangent in it, but remember that secant is 1 over cosine squared. So it looks like this second Pythagorean identity would be a good one. So if I just write down that Pythagorean identity, so again, I'm just referencing this. It's 1 plus tan squared t, or in this case, we're using theta, equals secant squared theta. Now I want to know the value of tangent. So I'm going to solve this equation for tangent. So I want to get tan squared by itself first, so I'm going to subtract 1 from both sides. That's going to give me tan squared theta equals secant squared theta minus 1. Which means that tan theta, if I square root both sides, is going to be plus or minus the square root of secant, try that again, secant squared theta minus 1. Okay? Now I cannot simplify this any more than it is right now. Secant squared theta minus 1 square rooted, I can't split up the terms. This isn't secant theta minus 1. That's not how square roots work. All right, so if cosine is negative, that means I'm in either the second or the third quadrant. If we think about the quadrants, that means I'm either in the second or the third quadrant, right? And since we're told here that we're between pi and 3 pi over 2, that means we are indeed in the third quadrant. And if we're in the third quadrant, that means the plus or minus here can only be one of those things, and that's plus, because tangent is going to be positive because both the coordinates are negative, x and y. And so for the purposes of this, we don't need the plus or minus. It's just going to be plus. Now we also know the value of secant because we know the value of cosine. Since secant is the reciprocal of cosine, this is negative 13 over 5 squared minus 1. And so you can use a calculator, but 13 squared is 169, and 5 squared is 25, and anything squared is positive. Minus 1, which I'm going to write as 25 over 25. And 169 minus 25 is 144. And so this comes out to 12 over 5. Okay. Now we've already done problems like this. So tan of theta in this scenario is 12 over 5. We've already done problems like this before. If I know that I'm in the third quadrant and the definition of cosine is x over r, if cosine theta equals x over r, that means x is equal to negative 5 and r is equal to 13. And if x is equal to negative 5 and r is equal to 13, then x squared plus y squared equals r squared. And so 25 plus y squared equals 169, which gives me y is equal to 12. And I get the definition of tangent, which is sine of theta over cosine of theta, or y over x. So that would be 12 over 5. Now notice that in this case, this would be plus or minus, so I would have had to choose the minus because I know I'm in the third quadrant. So then it would be negative 12 over negative 5. So we'd get the same answer, but I really want you to be using these trig identities, these Pythagorean identities, because this is practice for what we're going to be doing. Even later in this lecture, we're going to be doing some trig identities. And so being able to use this algebraic manipulation is a good thing. It's good practice. All right, let's do one more example, and then we'll move on to the next video. So if cotan of x equals negative 3/4, and we're in the third quadrant again, find the values of the remaining trigonometric functions. Okay, so the easiest to start with is I know that cotan is 1 over tangent, so that means that tan of x is equal to 4 over 3. It's just the reciprocal. I don't need to do any work for that one. Okay. But I don't know that this is a unit circle, so I can't say that cosine is 3 and that sine is 4. Sine of x and cosine of x is 3 and 4 respectively, because I don't know that they're unit circles. So to find something like cosecant squared, or cosecant of x, I think would be the next good move, because we have the trig identity that says that cosecant squared x equals 1 plus cotangent squared of x. That's one of our Pythagorean identities. It's the third one. The numbers don't matter, but I'm going to call that the third one. And we can see that if I square root both sides, that cosecant x, that cosecant x equals the square root of 1 plus cotan, but cotan's 3/4, so this is 3/4 squared. So that gives me the square root of 16 over 16, which is 1, plus 9 over 16, and that's 25 over 16 square rooted. So that gives me 5 over 4. So cosecant of x is equal to 5/4. And if I'm in the third quadrant, there is a plus or minus here that I need to be aware of. And the plus or minus in the third quadrant, cosecant, which is 1 over sine, in the third quadrant, both sine and cosine should be negative. So this will indeed be negative 5 over 4. If I know cosecant, then finding sine is the next obvious choice, because sine is the reciprocal of cosecant, so this is just going to be negative 4 over 5. So now the last piece is finding cosine. Now I could use a Pythagorean identity to find cosine, but I think probably the better choice would be to find, to use the definition of cosine, right? Or even using the definition of cotan, maybe. Okay? The definition of cotan, I'm going to do this down below here. The definition of cotangent is cosine of x over sine of x. And we already know sine of x, and we already know cotan of x because it was given. So if I just multiply both sides of this equation by sine of x, I have sine of x times cotan of x on one side, and I have cosine on the other. So I have an expression for cosine, and that's going to be sine, which is negative 4/5, times cotangent, which was given as 3/4. Notice the 4's cancel. I'm left with negative 3/5. So cosine comes out to negative 3/5. And then I'm just left to find secant, which is the reciprocal. That's easy enough. Secant is going to be negative 5/3. So here are the remaining 5 trigonometric functions. And I used algebra to do that. With all the identities that were listed back here. Okay, so I used the definition of cotangent on that one. I used this third Pythagorean identity to find the answers to the rest of these. Okay, so I'll see you in the next video. We'll do some more algebraic manipulation, but it's going to be more on expressions, which is going to lead us to our trig identity verification.